Chapter 2, Section 2.7, Part 2, solve each inequality, then graph the solution set on a number line. Number 4, negative 3x is greater than or equal to negative 12. All right, now when we're solving inequalities, it's very similar to solving equations, except you have to remember it when you multiply or divide by a negative number, you must switch the inequality symbol to the opposite direction. So it has to point the other direction. So let's look at this first problem. Negative 3x is greater than or equal to negative 12. You're going to have to divide by negative 3 to get 1x. So here we go, right off the bat, divide both sides by negative 3. At the same time, remember, switch your inequality from greater than or equal to less than or equal. All right, now you have to be careful here. You need to really write the problem over again. Sorry. You make the switch at the time you divide by negative 3. So since there was a greater than or equal, if we're going to divide by negative 3, right away we change that to less than or equal. Now I finished solving it, and that gives me x less than or equal to 4. Now, there's other ways to deal with this so you don't have to rewrite this step here, but it's kind of messy. So if you want to divide by negative 3 without writing a new step, divide by negative 3, you have to change greater to less than or equal right here. So cross it off and change it to less than or equal. You can't wait till the next step. That would be convenient, but if you leave it as greater than or equal, you've just written a false statement. Okay, so I'm still going to get, notice, x is less than or equal to 4 once you just simplify this negative 3 over negative 3 and negative 12 over negative 3, you have less than or equal to 4. You could actually do one more method where you take the opposite of all. So that's like multiplying by negative 1. So anytime you have a negative number in front of the variable, you could use this technique, but at the same time, you take also the opposite of that symbol as well. So this would give you, instead of a negative 3x, if you're changing the opposite of everything, you get a 3x. The opposite of greater than or equal will be less than or equal, and the opposite of negative 12 is 12. I'm using this opposite, loosely, but basically I'm changing the symbols. And now we've got a positive number in front of x, so we could divide by 3. And when you divide by a positive number, you do not need to switch the inequality symbol. Ran out of space here. Here we go. So we have x is less than or equal to 4. So 3 alternative ways to do this. So what I have here was method 3, right? That was one way I showed how to do it. This was method 2. And the first way was method 1. Okay? In all of these, we want to write what the solution is using a graph. So now we're going to do the graph. We're going to graph the solution on a number line. So let's draw a number line. And we'll let that be 0, 4, and negative 4. And what's it say? X is less than or equal to 4. So x is equal to 4, right? That's one of the numbers. And also, all the numbers less than 4 are solutions. So there are a lot of solutions in inequalities, right? Infinitely many solutions. We want to make sure we're going through the right points, so we want to check one of the numbers it goes through and see if that's really a solution to the original. So let's check an easy number, x equals 0, right? It's going through x equals 0 in the original. By the way, let's move this over a little bit. There we go. So we're going to check x equals 0 in the original problem, which was negative 3x is greater than or equal to negative 12. So we're going to put in 0 for x and 0 greater than or equal to negative 12. Is that true? Yes, it is true. Therefore, that's the correct solution. Next problem. All right, we've got variables on both sides. Let's put the variable on the right. That way it'll be positive and all the variables be on the right. So I'm going to subtract 7x from both sides. Now, when you subtract or add any number, it does not change the inequality. It's only if you multiply or divide both sides by a negative number. So this gives me 4 is less than 2x. And now we need to isolate the x, so we're dividing by 2. So I've got 2 is less than x. That's easier to read if I kind of read it from right to left. If 2 is less than x, then x is greater than 2. Think of this as an open mouth, and the mouth is opening toward the x no matter which one you look at, right? You could say that the little point right here, see that point? It's pointing to the 2 in both of them. So this is really two ways of writing the same thing. We like to write it with the x on the left side. It's easier to read. So now let's graph it. So we've got 2. I like how I make my graphs as easy as possible here. Don't have to get all complicated. X is greater than 2, so it's not equal. So you must put a circle on it, and that's to show that it's going to get as close as possible to 2, but just not touch it, and it's going to the right. Aha, finally a problem that doesn't go through 0. So now we're going to check it. So let's check one of the numbers it goes through. It goes through 3, 4, 5, 6, 7, 8, 10. Hey, let's check x equals 10. Can you believe that it's going to go all the way through 10? And we're going to check that in the original problem. So remember what the original problem was. It was 7x plus 4 is less than 9x. So remember, you need to check it in the original problem. So we're going to put 7 times 10 plus 4. Let's make that purple still. No, guess I can't do that. Is less than 9 times 10. So I'm going to do order of operations here on the left-hand side. 70 plus 4 is less than 90. 74 is less than 90. It's still true, so I have it going the correct direction. So this is indeed the correct solution and the correct graph. This is the exciting moment, the last problem on Chapter 2. The opposite of x is less than 0. Easiest way to do this is just take the opposite of everything. Right? Remember how I did that? Take opposite of both sides and change less than or equal to greater than or equal. I'm just writing down what's going on. If you do that, you get your answer. X is greater than or equal. What's the opposite of 0? 0. That's the end of the problem. How cool is that? So we have 0. Okay, greater than or equal to 0. So 0 is a solution. And we want all numbers bigger than 0. So we're going to the right. So let's check a number it's going through, like 2. Right? Can you see that it's going to go through 2? So check x equals 2. In the original problem, which was negative x is less than or equal to 0. So we're going to put in 2 for x. And is that true? Is negative 2 less than or equal to 0? Yep. That's it. Now, if you don't like this just taking the opposite of everything, you could have solved this. Negative x is less than or equal to 0. You could have solved it by multiplying or dividing both sides by -1. So you could think of this as a -1x is less than or equal to 0. And then you'd have to divide both sides by -1, which means this switches at that point. 0 divided by -1. And you're still going to get x is greater than or equal to 0. Right, so you'll get the same answer if you do it more traditionally, just dividing by the coefficient of x, but you do have to be careful. When you divide by a negative, you have to switch the inequality at that step. Congratulations, we are done with this. Only took 114 pages and 30 or so videos to get through Chapter 1 and Chapter 2.